Ladies and gentlemen, in this video, I'm going to show you how you can use integration to determine the area under the function. What do I mean by that? Let us get into it. Now, integration giving us the area. Say you have a graph like this. And in this straight line graph, let's say here you have the coordinates being 5:4. This will simply tell us that our y value is gonna be 4 and our x value is going to be how much? 5. It's going to be 5. Now, let us start by determining the equation of this straight line function. We're going to start by finding the gradient. The gradient is changing y all over changing x. Now, changing y is going to be how much? y2 minus y1 divided by x2 minus x1. Now, substituting the values, let's choose this to be our first point and this to be our second point. So this is 0 is to 0. The coordinates of the point of origin is 0 is to 0. So here we said is our first point, meaning we're going to say our y2 is going to be 0. So it's going to be 0 minus y1, it was positive 4. Positive 4. Our y1 is positive 4. Then divided by 0 being our x2, and then minus our x1 being 5. Now, this will simply tell us that the gradient will be equivalent to 4 all over 5. Now, going to our equation, remember the equation of the straight line is y is equals to mx plus c. Y is equals to mx plus c. Substituting our gradient in the equation, we're going to have 4 all over 5 x plus c. And then we need to now find the constant c. What is the constant c of this function? The constant c, we're simply going to pick one point. We're going to use the coordinate of the first point. You can use these ones as well, but it's fine. So you're going to use the coordinates of the first point. Y is 4, and then our x is 5. Our x is actually 5. We're substituting where there's x with the x coordinate. Now plus c. Here we're going to have 4 is equals to, this will cancel this, then you'll have your 4 plus c. You're taking 4 to the other side, you're going to get c to be 0. Then this simply tells us that the equation of this straight line graph is going to be y is equals to 4 all over 5 x plus 0. Or it's just y is equals to 4 all over 5. Now, the reason why I wanted us to determine the equation of the straight line is so that we use integration to find the area underneath this graph. Now I'm going to start by using the formula of the area for a triangle to determine the area of this part under this graph. First, before we use integration, just to prove that the integration can give us the area underneath the graph. So this triangle, in order for us to find the area of this triangle, we're going to say half base, this is going to be our base, and this is going to be our height. Our base is going to be 5 units, because we have 5 here, 5 units, and our height is going to be 4 units, which is 1. So our area is going to be what? Half base, 1 all over 2. The base is going to be 5, and the height. Half base times height, and the height is 4. Now, the area here is going to be 1 all over 2 multiplied by 5 times 4 is going to give us 20. Area is equals to 20 divided by 2 is going to be, or half multiplied by 20 is going to be 10. Now we know that our area of this triangle is 10. How can we determine that using integration? Now, integration, we're going to say area is equals to you use our integration bracket. Here on top, you're going to put your final position, the final position of the x values. So here we're going to have our 5, and then underneath you're going to put your initial position. So it starts from here and it ends here. So here is the final, here underneath is the initial, being 0. Now here we are going to place the equation of the graph. The equation of the graph is going to be 4 all over 5x. And then we are going to place what? We're going to place our dx to show that what is here is actually a derivative of a certain original function that we don't know of. We're going to determine using the integration. Now, we are going to first find the integration of this. It's going to be, remember, by integration, we need to reverse the power rule of the derivative. So the power rule tells us that you subtract 1 from the exponent of the variable. But then in integration, you're going to add 1, meaning we're going to have 1 plus 1, which is going to give us 2. So we're going to have x2. Then we take this 2, we divide the coefficient. So dividing 4 all over 5 by 2 is simply going to be like 4, it's simply going to be the same as 4 all over 5 multiplied by half, right? Now, we are going to put the big bracket and then insert our limit. We have 5 and 0. This limit is very important. Now let us continue by simplifying this part. This is going to be your 4 all over 5 multiplied by 2 is going to be 4 all over 10 x squared. Now, how do we incorporate this limit into our integration? Here we're going to, well, you can add c. We can add c here for the constant of the original function. We don't know if the original function had a constant or it didn't. So it's important to also include the c when you are integrating. Now let us further our simplification or our calculation. Here we're going to have a big bracket. With this limit, we are going to substitute it where there's x. Remember, I said this limit represents the final position in your x and your initial position. So you're going to substitute 5 here and then subtract the initial one. So you're going to take the final, you subtract the initial. So the final is 4 all over 10. And then we have 5. And then we're going to have squared plus c, close bracket, minus the initial. The initial is going to give us 4 all over 10, close bracket. And then inside the initial is 0. The initial position was 0 in the graph. So it's going to be 0, close bracket, squared, plus c, close bracket. Now we're done incorporating this limit into our integration. Now how do we further our simplification? Let us continue. We have our 4 all over 10, all over 10. Here we have 5 squared, which is going to give you 25, plus c, close bracket, minus, open bracket. Here we're going to have 0. 0 multiplied by this fraction is going to give you 0. 0 plus c. Let us continue. We're going to find, in this bracket, we're going to find 25 multiplied by 4 is going to give us 100, divided by 10. And then we are going to have, yes, you can close the bracket, then add your c, close the big bracket, and then subtract your c, positive c, because 0 plus c is just c. So now continuing, we are going to have 10. This side we're going to have 100 divided by 10, giving us 10. And then plus c, this negative is going to affect this positive. Negative multiplied by positive is going to give you negative. So you're going to have negative c. This is going to give us 10 plus c minus c. Then this is going to give us 10 for our area. Remember, we used integration to determine the what? The area. And the area here is the very same as the area that we found using our formula for the area of the triangle. Now in the next video, I'm going to discuss how we can use the integration to find the area underneath the graph, which is a curve, which is it can be any polynomial function. It can be quadratic function, or it can be any polynomial function. Thanks for watching, and thanks for tuning in. See you in the next video.